Okay, good morning, everybody. I'm going to pick up a few themes that were just introduced, particularly about standards, interoperability, the maturity of the utility industry and all of this. I've got 20 minutes to do it and a large number of slides. So I'm going to run through a fair amount of this. If we don't get finished, come and see us on our booth. So, firstly, I represent an organization called YSUN Alliance. It's an industry alliance promoting interoperable, standards-based wireless communications. So the key thing, particularly for utilities and smart cities, is that communications should be reliable and secure, but also equally importantly, interoperable. So we are an organization promoting this global ecosystem and accelerating the adoption of open standards-based field area networks. Even though many of you won't have heard of us because we're not so big in Europe, we currently have over 240 member companies representing 26 countries. Navigant research says there are about 90 million YSUN-capable endpoints deployed worldwide. So we're an established leader in innovation in smart solutions, promoting multi-vendor interoperability, vendor competition and customer choice, looking robust certification program for delivering interoperable solutions. And our ecosystem comprises product vendors, academic institutions, utility companies, silicon chip vendors. So the idea is provide a complete ecosystem from silicon to solutions. Target applications are smart utilities, and I'll come to a little bit more about this a little bit later on, particularly for our advanced meter infrastructure, peak load management and distribution automation. Smart cities, and particularly in Europe, there is quite a large number of deployments for canopy networks of street lights giving access to other devices to connect. Smart homes, this is particularly relevant in Japan, and I'll come to this a little bit later, but YSUN is currently being deployed in about 65 million meters across Japan, along with G3. So that's something that's worth considering. And then more and more deployments in other applications such as agriculture, structural health monitoring, asset management. Won't go through this list of companies, but you'll see that our promoter members include Cisco, Itron, Landis & Gear, Toshiba, Trilliant, all of whom are competitors in the utility business and in the IoT business for large-scale networks. So picking up on your comments, competitors have to work together to deliver interoperable solutions. And sometimes it's uncomfortable for them, but it's the way that we will set the future for particularly this industry. YSUN, as I said, is an industry alliance. We develop testing and certification programs so that just because you have a standard doesn't mean that products are interoperable. And because we're involved in the wireless space, and which is quite complex communication networks, we use independent test labs to do this testing. So it's very similar to the cellular industry, to Wi-Fi, and other organizations. So what are our communication network requirements for utilities? So, I mean, these are just 5 of them, but in my view, resilience and reliability. We're looking at, if you're looking at smart metering, you're looking at distribution automation networks, you need those to be highly resilient, they need to be reliable, There are situations, not so much in Europe, but in other parts of the world, where you have natural disasters and your networks need to be able to work and survive those and recover. So there are member companies that are supplying places like Florida. I think Itron is a member company. Itron supplied Miami, Florida Power and Light. There's some very interesting statistics on recoveries after hurricanes. Same within Tokyo, which is Landis & Gear, same technology or similar technology, good recovery times. Flexibility. So when people deploy networks, they don't necessarily know what they need in 5 years' time on those networks. They don't know how big those networks are going to grow or what technology they want to integrate in the future. So if you look at smart meter deployments now, initially they were just about meter reading. Now we're looking at how can you do load management, how can you do volt-var management, and that means how do you integrate those smart meter technologies, which have got so much more data than just the metrology, how do you integrate that into the DA network? So you need that future proofing from that point of view, and you need to be able to deploy things like edge intelligence in that. Scalability. Some of the smart meter deployments we're seeing are pretty big. Tokyo Electric Power has now deployed 29 million smart meters in Tokyo. That's quite a large network. Security is absolutely paramount. You don't want your network hacked. What more can I say? And longevity. And this is picking up a little bit on the telcos, and don't want to get contentious here, but maybe I will anyway. One of the things that has been noticed, particularly in the US, you put a smart meter deployment out, you want it to last 10 or 15 years. If you're using a managed network operator who is providing service, you want that service to still be there 10 years later. So there have been utilities that have relied on GPRS, and GPRS has been taken away because it's no longer economically viable. So therefore, longevity is important, and therefore the option to have the ability to manage your own network is equally important. And for large utility companies, that becomes pretty critical. I'm going to pick one particular standard that has a bit of history here. So in 2008, Pacific Gas and Electric, who supply power to the San Francisco Bay Area, and Florida Power and Light, who are Miami, both started deployments of smart meters for AMI of about 4 million meters each. And within the US, the situation is that spectrum regulations and the nature of the grid means that wireless mesh is a good technology to deploy. When they did this, they found a great technology from a California startup, but they didn't want to rely on that startup still being around in 10 years' time. So they decided to start a standards effort to take what was a proprietary technology and create a best-of-breed radio standard to support all of this. And this mesh networks use peer-to-peer communications, which has benefits for IoT generally. So in those days, there were a number of various field area network solutions. A company called Archrock, who were acquired by Cisco, which became what Cisco calls CG Mesh. Elster, who are now part of Honeywell, Itron, Landis & Gear, and Silver Spring were acquired by Itron. It was actually Silver Spring Networks that was that company. So it's probably just as well it was open standards based. So they all use similar technology, but there were subtle differences. So PG&E decided that it would be important to fund the development of a standard. The initial focus was smart utilities. The standard was optimized for very large-scale networks. PG&E were putting out 4 million smart meters. And the goal wasn't to come up with something brand new that may or may not work. This was a traditional industry that needed some sort of consistency, reliability. So take proven technology and provide something that was a global standard. So it took a while to do. This was in the very early days of competitors learning how to play nicely together. But we got there in the end. It was 15.4G that was published in 2012 and is now part of the 802.15.4 standard. There were quite a few successful outcomes, one of which was this backward compatibility with tens of millions of already installed smart meters. And there's a lot of flexibility there, which is good in some ways and makes life difficult in other ways. One of the key things was the support of IPv6 directly on the radio. For those of you that know Zigbee, for example, Zigbee uses very small frame sizes, as does LoRa, as does Sigfox, which won't carry native IPv6 frames, which makes it difficult to do a number of things like deliver IP address right to every node on the network. So the standard came out. We supported a whole range of global frequency bands, and this has actually been increased through standards called 15.4U, which addressed India, and 802.15.4V, which amongst other things has addressed opening up frequency bands in Europe, which are, I think, opened in about 15 European countries now, which include Europe, UK, Nordics, quite a lot of Eastern Europe as well. So what does Wi-SUN do? We define these profile specifications. We have two significant ones. On the left-hand side are field area networks, all open standards-based, basically wireless mesh with fairly sophisticated security. On the right-hand side, we have a home area network profile that was originally developed for Japan. I suspect I don't have time to go into the details of that, but this is what's being deployed in 65 million meters across Japan right now, along with side-by-side with G3 PLC. So what anybody ever... You will visit a number of comms providers here and they will tell you what they've got is the best solution for all their problems. Don't believe it. There is no one single communications technology that solves all the problems in the utility industry because they're so big. So the key thing is being able to support heterogeneous networks where you can mix technologies but still run common application platforms. How am I doing on time? No, I've still got lots left. How am I doing on time?
How am I doing on time?
Yeah.
2 more minutes.
Pardon?
1 more minute. We are running out of time.
Okay, so I need to run through this quickly then. So Wi-SUN Field Area Network is a multi-service network. It runs IPv6 natively with high security, supports frequency hopping, and as such you can run a whole load of different utility type applications over it, particularly in smart metering, distribution automation, but also in things like street lighting. So for example, Florida Power and Light have 4 million smart meters. They also manage the street lighting network, and then they installed 500,000 street lights on that same network several years later. Quick look, architecture. Wi-SUN is about the field area network mesh. It doesn't stand alone. It needs to connect onto a backhaul network for which you can use cellular. You can use a private network, which a number of companies are doing, so it could be private cellular, or in some North American venues they're using WiMAX still, or it could go through a fiber Ethernet connection. And on that mesh network, you can support a whole range of different applications. going back to your talk about protocol stacks, this is for the engineers amongst you. The key thing here is this is a standard open systems interconnector architecture. From our point of view, all of the stuff at the bottom is open standards based. A lot of it reflects what's already going on in the internet. So why reinvent the wheel? The internet has solved many of the problems that are there for the utility industry. How do you provide reliability and resilience? How do you provide good security? So what we've done within Wysun is just take a selection of these standards and create a recipe for an interoperable solution. I will show this slide and then I'll stop. For those of you that understand security, this sort of architecture is what you might see in an IT deployment. It's an enterprise security architecture, but you can similarly run it on an OT network. So the various software components, hardware routers, etc., can be replicated, the skills can be replicated. We're using the same sort of certificate-based management for device authentication that you would use in an IT network. So I'm not proposing you mix your IT and your OT networks, but you can have transferable skills, you can have transferable technology. I've overrun my time. There's a lot more of this I could talk about, but I think it's time I gave it back to you.
Fantastic, Phil. Thank you very much.